Hello and welcome to Robert Morris University Math 0900. This is Brianne Hernick and we are now beginning Chapter 7, Lesson 4. In this lesson, we are going to focus on three main objectives. We are going to learn how to write the equation of a line given a point and the slope. We're going to write the equation of a line when we're given just 2 points, and we're going to write the equation of a line whenever we're just given the graph of the line. There are no new vocabulary words for this section. So we're going to go ahead and move on to the first topic, which is writing the equation of a line given a point and the slope. I'd like you to pay attention specifically to the two items that you're given here, the point and a slope. Now, I teach this section differently than how your textbook does. So if you're not particularly fond of the way that I teach it, you might want to refer to the textbook and read through the examples there, as well as some of the online content from the textbook. That could help you out as well. But this is the method that I prefer. I do feel that it's much more direct and gets you to the answer quicker than what the textbook shows. Now, when you are given a point and the slope of an equation, the most effective way to write the equation is to use what is called point-slope form of the equation. And the point-slope form of the equation is the equation that I've just circled here. Y minus y1 equals m times quantity x minus x1 plus b. Once you substitute in the values for the point you have been given and the slope, you can simplify the equation down to just slope-intercept form. So the y and the x without the subscripts are always going to stay in the equation. They are like the y and x that we see in y equals mx plus b. The y1 and x1 are going to come from the point that you're given. M is going to come from the slope that we're given. Again, your text teaches this differently. Their method works exactly the same way, but you're just going to have to substitute back into the equation once you're finished simplifying. My method doesn't require any substituting. We're just going to plug those points in and simplify right there. We don't have to do 2 steps, whereas theirs is kind of like a 2-step process. So let's take a look at example 1. It says find the equation of a line that passes through the point negative 3, 6 and has a slope of negative 2/3. So as you can see, we were given a point and we were given a slope. So the most effective way to write the equation of the line is to use point-slope form, hence the name point-slope form. We're given a point and a slope. That's what we want to focus on here. So what we do is we're going to plug in the y value from the point for y1. So I'm going to go ahead and substitute in that 6. So I have y minus 6. My slope was negative 2/3, so I'm going to make that substitution. And then I'm going to plug in my x value, which was negative 3. So I have x minus negative 3. And close that parenthesis out front there. At this point, I want to distribute in my fraction of negative 2/3. So I have negative 2/3 x. And a negative times a negative technically makes a positive, so we can think of that like an x plus 3 in there. So when we distribute negative 2/3 times positive 3, that is going to leave us with negative 2 because the 3's will cancel, or you can think of it like negative 6 over 3, which divides down to negative 2. The next step here, after we distribute our slope, is to solve for y. So we're simply going to add 6 to both sides, and y equals negative 2/3 x plus 4. We now have an equation that's written in slope-intercept form. So what I would like for you to do at this time is to do student practice 1. Remember, we're using the form y minus y1 equals m times x minus x1 as our equation. That is point slope form. Please pause the recording, plug into the equation, and simplify it down to slope-intercept form. Please press play as soon as you're ready to check your answer. Okay, at this point you should be ready to go over your answer with me. You should have plugged in a 12 for y1. Our slope was negative 3/4, and then we're going to have x minus negative 8 minus a negative will turn into a positive. So I'm just going to go ahead and write that as a positive right now. The next thing that we want to do is distribute in our slope of negative 3/4. So we have negative 3/4 x, and whenever we distribute to the 8, we want to think, how will the 4 and the 8 cross cancel? Because that's like a fraction. So the 4 will become a 1, the 8 will become a 2, and then you can straight multiply. Negative 3 times 2 will make negative 6. We could have also thought of that as negative 3 times 8 would give us negative 24 over 4 times 1 gives us 4. 24 divided by 4, or excuse me, yes, 24 divided by 4 gives us the 6 right there. So two ways to think of it. The last step here is to solve for y, so we will add 12 to both sides, and we have y equals negative 3/4 x plus 6. And that is the slope-intercept form equation of the line that passes through those points, or through the point and with that slope, I should say. The next section is a section where we're given just 2 points, and we're told to write the equation of a line when we're given those 2 points. So the steps here are to first calculate the slope using the slope formula that we learned earlier in this chapter. Next, you would choose just one of the points that you were given, it makes no difference which one, and substitute it into the formula for point slope form, and then solve and simplify until you have your equation. So let's go ahead and take a look at example 2 of how this will work. The first thing that we want to do is calculate slope using the formula delta y over delta x. So remember, that's the formula y2 minus y1 over x2 minus x1. It made no difference which point we used as 1 and which point we used as 2. Please remember that. So I am going to go ahead and plug in a 6. No, I'm not. That's an x value. One moment. I am going to go ahead and plug in my 3 for y, my 6 for x. So I'm using that point as my y2. Then I'm plugging in the minus from the formula, and then we're going to choose y1, which is 5, and x1, which is 2. So that was my 1s right there. Now we're going to simplify the formula down just doing the math. 3 minus 5 is negative 2. 6 minus 2 is 4. We want to simplify our fraction as much as we can, So that's going to simplify down to -1/2. So that means that our slope is a slope of -1/2. Now that we have identified the slope and we have a point, we can use point-slope form. It makes absolutely no difference which point you choose. You can use either one in the equation. It's not going to matter. I'm going to use 2, 5. So I'm going to plug in 5 for y1. I'm going to substitute in my slope of -1/2. And then I'm going to plug in 2 for x1. And we're now going to begin to simplify and solve for y. So -1/2 times x makes -1/2 x. -1/2 times -2 is going to make a +1. Lastly, we're going to add 5 to both sides, and y will equal -1/2 x plus 6. And that shows us our slope-intercept form of the equation that passed through the two given points. I would like for you to go ahead at this point and try student practice 2. Please pause the recording. As soon as you're ready, please press play and we'll check your answer together. Okay, at this point you should be ready to check your answer with me. So I'm simply writing in the slope formula for us to use here. I have y2 minus y1 over x2 minus x1. And again, it makes no difference which point we use as 1 and which point we use as 2. So I'm going to use 3, 5 as 2, and I'm going to use -1, 1 as 0.1. So my y2 value is 5, my x2 value is 3. I'm going to plug in the minus from the formula. My y1 value is 1, my x1 value is -1. We need to simplify. 5 minus 1 makes 4. A double negative is the same thing as a plus, so 3 plus 1 is 4. 4 over 4 becomes 1. That means that this equation had a slope of 1. Next, we will plug this all in to point-slope form, which is y minus y1 equals m times x minus x1. Again, it makes no difference which point we use. I'm going to use 0.1. So I'm going to plug in y minus 1 equals 1 times x plus 1, because minus a negative turns into a plus. At this point, distributing in a +1 will do absolutely nothing to our quantity. So I'm going to remove my parentheses because I do not need to distribute a +1. We are now ready to solve for y, so I will add 1 to both sides, and y equals x plus 2. This shows us that we have a slope of 1 and a y-intercept of 2. So that is how we were able to write the equation of a line that passed through the two given points. The last topic in this section teaches us how to write the equation of a line when all we're given is the graph of the line. So we have two pretty easy steps here. The first thing that we want to do is identify the y-intercept from the graph. After you identify the y-intercept, You simply want to use the slope by using the rise and run as we move from left to right on our graph. So let's go ahead and do that. As we look at our y-axis, we can see that the y-intercept was a positive 4. So the next thing that we want to do is identify the next point where we can see that our line is going to fall perfectly on one of the little grid lines that shows the intersection of one of our integers so that we can count the rise and the run. As I'm reading from left to right from my point, my intercept, it looks like, let me get that little keyboard off of there, it looks like the next, I call them perfect points, where the line is going to fall on one of the grid lines, is right there. So what we want to do next is count the rise and run. So we're simply going to see how many grid lines, how many units did we have to move down. That's going to represent our rise. And since our line is slanting downward and we're falling instead of rising, that tells us that our slope is negative. So we're going to go ahead and put that negative in so we don't forget. So we're going to move down 1, 2, 3, 4, 5 places until we would run into the grid line along the y-axis in which that point that we made will fall. So far I have a negative 5 for my slope. Next we want to calculate the run. So we're going to see how many units we need to move over to get to our point. So we would move over 1, 2, 3, 4 units to the right. So the slope was negative 5/4. Now keep in mind that we use the intercept and the slope. So that tells us that we want to use slope-intercept form. We're simply going to plug in the slope of negative 5/4 and plug in the y-intercept, which was positive 4, and we're done. We have now written the equation of that line looking only at the graph. We found the y-intercept and we used rise and run to get to the next point that fell perfectly on one of those grid lines. So what I would like you to do now is do student practice 3. We want to go ahead and do the same thing. Identify your y-intercept, identify your slope using rise and run, and then write the equation of that line. Go ahead and pause the recording. As soon as you're ready to check your work, press play, and we'll go on and check it. Okay, at this point you should have completed student practice 3 and you should be ready to check your answer with me. As you look for your y-intercept, you're going to look for the place along the y-axis where your line intercepts the y-axis. That occurs at positive 1. So that tells us that our b is a positive 1. Next, using that point that we just identified, we want to use the rise and run until we get to the next point that will occur on one of the grid lines, or in this case, a point that was given for us, right there. So we're going to use the rise. Now our line is slanting up, and we would have to move up in order to get to the next point. So that tells me that my line is positive. Excuse me, that my slope is positive. So how many units did we have to move up? Just 1. So my rise is 1. And now we're going to calculate the run. How many units will we need to move over? Let's count. 1, 2, 3, 4, 5, 6 units. That tells me that my run was 6. So my slope is a slope of positive 1, 6. We can now plug these two values into slope-intercept form. So we have y equals 1/6 x plus 1. And that is the slope-intercept form equation of the line that was graphed at the left. That completes the lesson for Chapter 7, Lesson 4. If you have any questions about any of the topics that we covered, please feel free to contact me and I will be more than happy to go over them with you. Thank you.